Okay, next we have Schuyler Wolff, who's going to present designing the observation phase of the Roman Coronagraph. Thanks, Schuyler.
Thank you, everybody. So yes, I have a lot of material to get through, and I want to leave some time for questions. But I'll just mention that I'm presenting this work on behalf of a large CPP team. Many of us are here, so if you have questions about this throughout the rest of the week, please come talk to us. So I think we've had a great review from Bertrand and Eric. These are some of the salient points to keep in mind for the remainder of this talk. We have an observation phase that lasts for 90 days within the first 18 months of the mission. Today, I'm really going to focus on the first 6 months of that time, where we're really doing a lot of the instrument checkout. The assumption is that we will learn a lot. We'll be able to characterize the performance, and has been brought up in the Q&A, start doing more ambitious, riskier things over the lifetime of this observation phase, with potentially more opportunities for feedback from the broader community. The primary goal, of course, within that first block of time is this TTR5 demonstration. But again, we're going to be pretty ambitious here within the first 6 months and really push both in terms of high scientific impact, but also technology demonstration activities. And all of the data is public, so we welcome all of your help in analyzing and characterizing all of this data that I'm going to be presenting. So a big part of designing this observation phase came from community input. This had 2 main flavors. The first is the community interest survey that happened about a year ago, launched at AAS last year. And one of the key takeaways from that was that the community seemed to have a strong sense that both imaging and spectroscopy of Jupiter analogs in reflected light was a very high priority for the Roman Coronagraph, so I hope you'll see that reflected in the OBS plans. And I think the main goal of this community interest survey was to try to assess whether or not the goals of the community differed in large ways from the CPP team, and make sure everyone was on the same page and we were developing tools in the right areas. A more detailed opportunity for feedback came in the white paper call that happened last summer. I think many folks in here probably wrote white papers, and I appreciate your service. We had over 80 white papers submitted, which kind of is more than double our expectations based on similar white paper calls. And I think that really demonstrates how important this instrument could be to the community. And so I think there's lots of good spread between technology demonstration activities and science proposals here. And so I'll briefly summarize some of the key themes that we're using that came out of those white papers and are sort of providing guiding principles for the observation phase, especially in the early mission. So Bertrand already mentioned most of these. We had a lot of white papers suggesting please do imaging, spectroscopy, or even polarimetry of my favorite planet, right? Both self-luminous and reflected light planets. We also had some really nice papers advocating for exozodi. This is a key source of uncertainty for HWO. And so both digging deeply on high priority HWO targets, but also quantifying, what are these Zodi levels we're measuring in the infrared? What do they equate to in scattered light? So that's a high priority for us. A lot of disk observations were advocated for as well, both in terms of using them as technology demonstrators to really quantify the polarimetry performance using well-characterized disks. Also looking to push down to fainter host star magnitudes for some of these more moderate contrast disk systems. But then, of course, there's lots of science potential for these disk observations. So looking at scattering properties and scattering phase functions and colors from existing observations to look at grain particle properties within the disks. And also looking at the morphology of some of these transport-dominated systems with lower infrared luminosities and getting down into the warmer asteroid belt sort of analog regions for a handful of systems. Lots of exciting potential there. And then we had sort of 2 main themes that came out with regards to technology demonstration. One, of course, we've already touched on is this model validation. So over the course of this observation phase, trying to understand how the contrast, the dark hole performance and stability change with time across various axes in terms of host star properties like the magnitude, the stellar diameter, the color potentially, but also in terms of the observatory. What do large sloughs do to our contrast? Lots of examples listed here. And then we had another camp of white papers that was really focused on providing ideas for alternative wavefront sensing and control modes. I won't discuss this much today because I don't have time, but I think there are some posters on this and lots of people in the room thinking about this. So how do we turn these main science themes into an observation plan? One of the key limitations here is our schedule. So here's a brief schematic. You've already seen versions of this in the previous couple of talks. Launch, oh, right. Yes. So the launch window is currently late September to May of 27. We're working towards the earlier date there. So, today we're about 9 months out potentially. So lots of work to do, but we could see results very soon. Following launch, we have this 3-month commissioning period, and then that observation phase. Assuming a late September launch date, the observation phase would start in January of 27. And so that's sort of the 6-month block we're considering going forward. Within that, we have the further constraint of the wide field instrument observations. One of the main things to consider there is one of the core community surveys, the Galactic Bulge Time Domain Survey, which has sort of these blackout dates from early mid-February to March. And that's required to meet their science objectives. So these are blackout dates both for Roman CGI and for other WFI observations. So you might hear me consider observations pre and post galactic bulge season, because that's a lot of how we've been thinking about this. One nice thing about this break, our engineering team is going to be pretty exhausted coming off of commissioning, and then we're going to have a month of pretty intense observations. So this gives us a nice period to process the data, analyze the data, and see if we want to do any strategy changes for the second half post-bulge season. A couple of caveats before I start talking about specific targets. This assumes a launch date. That launch date, there's a nice long window there. And so the specific targets could change. These are not currently set in stone. But I think the overall themes are unlikely to change. I think the targets that are most sensitive to launch date are going to be the reflected light planets because they are the most time sensitive due to the phase. So there's targets that are optimal in January that are not going to be optimal in May. All right, pre-bulge. We're going to exercise. Band 1, both narrow field of view and wide field of view. This gives us lots of redundancy on TTR5, and we also get to do tons of incredible science. Okay, so I think one of the things people are excited to see here is that we are going to attempt to image 2 reflected light Jupiter analogs in the first month of observations, EPSARI B and UPSAN D. We're also going to do both debris disk and exozodi observations for EPSARI and Eta Corvi, both have strong Zodi detections. And we're going to attempt to characterize our polarimetry with HR 4796. Interspersed among all of these exciting science observations are a series of technology demonstrations. As I mentioned, we want to go really deep, both on HLC narrow field of view band 1 and the wider field of view band 1 observations in both imaging and polarimetry. That's our goal. We also want to understand faint star performance. So our nominal limit is 5. We think we can go down to 7th. Without much performance difference. We can possibly go down much further than that, but we need to test that process. So we're going to do that early on to potentially open up other opportunities for targets. And then we're also going to do some screening for reference stars for bright companions. This is to mitigate risk in later observations, and you can hear more about why that's necessary in the talk after the coffee break. I wanted to highlight, there's been a lot of hard work on the part of the CPP team and largely driven by the community to understand exactly which of the reflected light planets to go after early on in the mission. And many of these folks are here, and I encourage you to go talk to them about this. All right, post-bulge. The goal is to exercise all of our best effort modes within the first 6 months. So moving on from band 1, we're going to exercise band 3 spectroscopy a couple of times, getting more ambitious each time. And we're also going to look at wide field of view band 4 imaging. So we're going to start off with the spectroscopy campaign for a couple of sort of more moderate contrast objects to commission the mode. One that fits easily in the field of view, and then another one that's really close to the inner working angle to push performance down there. And then we're going to move on to wide field of view band 4 observations, and we'll be interleaving some self-luminous planet observations alongside a bunch of disk observations. And the disks will probe both that dust transport, and also we're hoping to get some disk-planet interaction observations in there. Another mode we're going to be trying to test in the first 6 months is this star hopping mode. So here, for objects that require more moderate contrast floors, for stars that have a similar V magnitude and are close together in the sky, you can skip some of the HOFUS and LOFUS star cold digging. And so you can save a lot of time. But you can expect the contrast to also degrade. And so we'd like to test this out, see how our contrast stability is as we slew to different objects across the sky. And to do that, we've identified disks as a good candidate for this because they tend to be a little bit brighter than a lot of the planetary systems. And there's a set of observations in Upper SCO that we're hoping to conduct. Then moving on to a more challenging spectroscopy target, HR 8799E, hoping to do that within the first 6 months. And then we'll also finish with a set of band 1 observations again, hopefully having learned something from the pre-bulge season activities to go after many more of the ExoZodi targets and our ExoZodi pilot survey. And then there's a couple of objects we're hoping to try. This might get pushed to a later semester. But for a couple of bright debris disks, we want to help characterize the scattering phase functions and morphology. The problem here is HD 163296 is only visible for 2 days outside of the bulge season this semester. So this might be tricky to schedule, but we're hopeful. But stuff that can't be done this semester can always be deferred to future observations. Again, lots of excellent work done by the CPP team. Many of these folks are here, and please come talk to us. So if you didn't see your favorite object or your favorite science theme here, we're aware that there are lots of other exciting things we could be doing. What we've prioritized in the first 6 months is the highest science impact and the lowest risk. But again, as the mission continues, hopefully we can expand that. And hopefully, once we're able to better characterize CGI performance on Sky, there will be future community input opportunities. It takes a village, so I just want to briefly acknowledge all of the hard work by the CPP team, the Roman project team, and also the teams, many of who are in this room, who came before, the SIT teams, the people who got Roman off the ground at the beginning. And I'll just flash this again. These folks are CPP members who are here, and we're happy to talk to you more about this. So thank you.
Questions? We've got one here to start.
So thanks for a very nice overview. I'm wondering if there's any opportunity for repeat observations of a target, both in the sort of demonstration sense of seeing just how repeatable the observations are in terms of contrast or artifacts, but also potentially as a segue to variability observations. In particular, we're probing close to debris disks. We might be looking for time domain phenomena of interest, which we see in other wavelengths.
Yeah, Yeah, so I think we're not planning on doing any revisits within the first 6 months. The goal is to kind of go broad, but that's certainly an opportunity later in the mission. And I will say a lot of our reference star observations will repeat. We will likely use the same reference star for multiple observations, and that should give us a really nice metric of the stability on a specific reference star over time.
Will those reference star observations be repeated inside the first 3 months, or?
Likely, yes. I don't want to steal Justin's thunder, but yeah, we have a small set of reference stars that we're fairly confident don't have companions that would break the Wolff star coal digging, and so those will likely get well exercised within the first 6 months.
Back there, yeah.
Thanks, Schuyler, and also Eric. This is really exciting to see that the technology demonstration that's coming up here, but this is also a new way of doing a observing program. This is not a Spitzer key science program. This is not a JWST GTO team. This is its own unique, different way of organizing the community over a 6 to 18 month time period. So I'm curious your thoughts on and your plans for communicating with the rest of this interested community and balancing the tension between bringing in all the brain power and interest that there is, and also not getting in the way of the people who are on the front lines working day by day. And so just tell me your thoughts on that.
Yeah, it's, for example, these white papers, we've had them for a while. We haven't been sitting on them. We've been doing a lot of work trying to tease out the best information we can out of them. We are planning on putting together a formal report on the white papers we received, hopefully later in this spring. But yes, I think it's a very good point that, time spent providing information to the community is time not spent further developing observation planning tools, getting more precise estimates on exposure times, for example. So we're hoping once this schedule gets nailed down with a bit more specificity, we've been in chats with Nexi to put together a formal target list in a similar way to the HWO target list. And then I'm hoping that allows opportunity for the community to organize itself to try to analyze some of these observations as they're coming down from Roman. But again, if you have ideas on how best to do that, I'm open to hearing more about that.
Hi, Sarah Steiger, Space Telescope Science Institute. I was wondering if there were any plans for concurrent observations with other space or ground-based facilities?
No. That's the short answer. But if you have ideas, we'd love to hear about them.
Okay, maybe one more for the coffee break. Yeah.
You've spent most of your time talking about reflected light planets. The first two points on your schedule listed demonstrate TTR5, including the companion that Mona found. Yeah. Could you discuss that in a little bit more detail?
So yeah, I think the plan is to front load band 1 observations of targets that have the lowest risk of a non-detection. And that's one that I think fits, it's like 10 to the minus 6 we estimate in band 1, which would fit squarely in a TTR5 demonstration. Yeah.
All right, let's thank Schuyler again.